Hello everyone, my name is Rick Gurgitz. I'm the Complex Service Manager for the Red Power Stores. We're a group of 10 stores in northern Iowa. And welcome to my series of videos on combine settings, adjustments, and basically just trying to understand how our combine works. So over the years of doing combine clinics, it's great to give out information, but there's a lot to go over on how to make our combine work correctly and make your harvest go easier and better results. So what I've decided to do is I'm going to take basically the contents of a combine clinic and I'm breaking it down into different sections. We're going to do a section on feeder, threshing, cleaning and sieves, automation, just breaking it down into smaller snippets. So we're going to get them on YouTube clips that will be put on our company website, and you'll be able to go reference those whenever you need to. Because again, clinic's great, and I love it when all you come because it's really good interaction, questions, and I learn a lot from you as well as the other way around. And I want to make it in a more usable format for you as you go forward. So again, if you get out in the field during the fall and you're having trouble remembering a segment, you can go to our website, pull up that particular YouTube clip, run through it. You can speed it up, slow it down, back up, do whatever you need to. And again, as we go along, I need the feedback from you of what I'm missing. I'm just trying to do a general overview of what I think you need. But again, I can adjust these season to season if something new comes up and add or subtract, do whatever we need to. So thanks again for watching. We'll have, like I said, several different segments as we go through. In this segment, we're going to cover the threshing components. So really kind of the heart of the machine in some regards. But we're going to cover what parts make up the threshing system, how it functions a little bit, and what different types of settings we have for it, and different concaves and all that type of stuff. So we'll dump right into it. So as we talk about the threshing, or the heart of the system, what parts make it up? Well, of course, we've got our rotor cage up here. Of course, the vanes are attached to the upper part of the cage, and then we have our sections with threshing concaves and then separation concaves, I guess you'd call them, in the back. So the first thing we always want to remind everybody is we're looking at 4 different sections. You have 1, 2, 3, and 4. These 2 are, again, threshing, and we're going to say probably 80% of separation up here also. Depends a little bit on your crop, yield, what that percentage flips back and forth to. I'm going to say soybeans, the lighter crops, you're going to be probably 80% thresh, and then, 100% of the thresh, 80% of the separation. And then back here, we're going to finish up the separation. Corn, once you start getting into higher yield stuff, that's probably going to go to more of a 70-30 split. And that's fine. We've got some different things we can add in there when we get in that scenario. And there's a lot of other factors that play into how successful we are with all that. But if we start with concaves first, again, we can see we just have some standard large wires in here. And back here we have the large skips. In a little bit, we're going to look at a whole bunch of choices of what we have for components to put in there. I've got a section where we've got the concaves laid out on the floor and a rotor hanging above them, so we can kind of get a better idea visually. It's a little bit hard here to get the whole concept down of the different choices available. But as we look at this with our concave bed, we can see several different things here. We have, of course, the electronic concave adjustment for open and closed. We have the bolts here that stop or limit the closing of the concave, so basically zeroes it out, prevents the concave from ever traveling to the point where it's actually going to make contact with the rasp bars on the rotor. And then also we have another component here of leveling this concave. So there's some components here that typically should never have to adjust. They're checked during PDI, and unless we're suffering from rock damage or something, we should never have to adjust this. As well as the pinch point. A little bit hard to see in here. We've got another segment later where you can understand that a little better. Pinch point basically deals with where the rotor is closest to the concaves. And again, concaves and the rotor are a bit elliptical, so it's not a true circle, so there is a pinch point. And what it has to deal with is how it distributes the grain down on the grain pan. Like I said, we'll get into that a little deeper in some other segments. But again, an adjustment we shouldn't have to really adjust on our own. The other one that is adjustable, and depending on the vintage of your machine, we're talking about vanes up in here. Can't totally see them again, but we have the in-cab adjust option now on the 50 series, or electronically adjustable vanes. There are actually 6 vanes that move in conjunction with that, from basically here back. There still are 2 manual adjust vanes in the very front of this rotor cage up here, and those are typically going to be set in that medium position. But then again, back here we can adjust these on the go, and automation can also adjust those on the go. One other point to make in this particular segment on concave adjustment is we have to remember, even in automation, it does not adjust the concave on the go. That is just one section that's not included in automation. We can do rotor speeds, vane settings, a lot of other things within the rest of the machine, but concave adjust, we're still relying on the customer getting a good solid setting in there. And we've got some more segments on that of where that needs to be adjusted for the crop type that you're in. But extremely important to remember that in automation, and we have a segment on that also later, is if this concave adjustment is way off, it's going to affect the way the automation works. So that's one thing to remember also within automation. If we're struggling with it a little bit, maybe we got to tweak our concave setting a little bit to get that where it's at. Again, we have a multitude of choices of where we're putting concave between round bars, large wires, and whatnot. The one thing that does always hold true is, again, we have left and right side. On the other side, number 1 section on the other side, in my book, should always be a large wire. Reason for that is, and again, soybeans, that would be the best choice anyway. But once we get into corn and we're starting to think more round bars, putting a round bar over number 1 right will work. Unfortunately, it works too well. And you get some drier corn, it'll thresh really hard because that right front corner, because of the rotation of the rotor, threshes a very large percentage of the grain. I'm going to say that first corner is probably doing 70% of the thresh right there in that first pass, and then we finish it up as we make the revolutions through the rest of section 1 and 2. But that right front corner is the really active spot for threshing and separation. So as we're doing that, if we happen to have a round bar over there, we flood the right side of the grain pan, which creates problems for us as it moves rearward into the sieve. So again, leaving a large wire in that front right corner will prevent that overflow or flood of grain coming down through there. Some other things we will run into is plugging these as we're going along with dry, or I'm going to say more of a green material, or shagging these. Not so much in soybeans, but more once we get into corn. Then that's when we can start putting some round bars in there. And that helps prevent that. If that right front corner starts to look like it's plugging a little bit, don't worry about it. In corn, it's actually helping you. So there's no real worry with that in that other corner over there, because it's still threshing on the inside of it. It just looks bad when you take that side panel off. Ignore it, it's fine. One thing we have run into, if you pull your side cover off here, and let's just say the machine, you have yours set up exactly like this, and you're in soybeans that are the situation we run into quite a bit anymore, where the stems are super green, we got a lot of leaves hanging on, but the beans are 10%. So we can actually harvest and the beans are fine, but what we're running into, and especially it seems like it's worse with beans that have had fungicide sprayed on them, those stems just don't want to die. And if we open this up and you're starting to plug from end to end in that green soybean scenario, we don't have a lot of good options for that other than letting that crop mature a little bit. Even you can't really go to round bars because you struggle getting the pods threshed open in that scenario. You really still need the large wires, and sometimes you're plugging from end to end. And like I said, in those scenarios, we don't have a real good option to clean that up. And that scenario will affect about any machine out there. If that straw coming in there from that bean straw is that gooey and gluey, as we start to thresh it and break it up a little bit, it just coats everything with a sticky substance, and then it just starts plugging. So just one thing to be aware of in that scenario. The other thing I run into a lot, talking and working with customers, especially in corn, the one thing that'll affect this the most is running the rotor too slow. In my book, 380 is about the minimum you want to be in corn, and then we're going to throttle our concave opening to control a good thresh and grain damage, those two other factors. And you can do that by opening the concave a little more. Some of those scenarios where we get out there where wanting to run that rotor at 350 or 3 1/4, got the concave pretty tight. Yes, you can thresh grain at that level, no settings. But the one thing it does do is it kills your throughput, and then it also affects how well the feeder is functioning. Because just as this example, and this concave is about wide open, it just happens to be where they left it out of PDI. You can get a lot of material through there if that rotor's spinning pretty good. If we close this way down, pinch it down, we can't transition the crop mat out of the transition cone into the rotor cage very well. And a lot of times on those scenarios where we're running the rotor really slow, all that does is it starts back feeding the feeder, because the material, our crop mat's coming up, the feeder house nice, we get it through the rock trap to the transition cone, it's got nowhere to go. So at that point, all it can do, it starts flipping around, going down the top side of the feeder and going around for a second time, and that's where you get ears shooting out of the front of the feeder house down that top side. And again, it's all about throughput and how much of an opening we have for that material to transfer from the transition cone, get it in the cage, get our thresh and separation started. So again, key point, keep that rotor speed up in corn. I like 400 a lot of the time. If you get super dry corn, maybe down to 380 as a minimum. We get in tougher corn, we're sometimes up in that 4 1/4, 440 range. Just kind of depends on what we've got going for our crop yield, moistures, and things like that. Another thing I want to point out for corn is if we get into a rubbery cob situation, not always, a lot of times it's a white cob variety. This setup right here has been working as well as anything, and that's where we go back to large wires all the way through. We do have to play with our concave opening and occasionally do have to play with our rotor RPM in those scenarios. What I've seen with if we have the full array of round bars in, where we have our large wire in the front right, 3 round bars surrounding it, and you'll get a better view of that here in a little bit, is what happens is that round bar won't thresh that cob very well. That cob wants to twist every time it touches something in there rather than thresh the kernels off. And it is pretty soon it just starts breaking the cob up. And anytime I've told customers when we get in a rubbery cob situation, go back to this setting here, put the large wires back in. We may have to play with our settings a little bit, and it's a trade-off. In those varieties, you're trading off how much cob you end up with in the tank versus how much we leave on cob pieces going out the back. It's a fine line. You're going to end up with a few more cob pieces simply because it breaks them up a little bit as we go through here. We start flooding our sieve system just because we have a lot of cob pieces in there, and then it all transitions back and we just can't get the sieves, get it all out because the pieces are too much the size of the corn and it ends up in the tank. So just one thing to remember on that rubbery cob scenario. So here we've jumped to just a little bit older machine to show you kind of a better view of the manual adjust vanes. Again, here a quick view. This one happens to have a pair of round bars in up here. I can't tell what's on the other side, but again, just a view of what round bars there are in section 1 and 2. Cut. So here we have a shot of our manual adjust vanes, and you can kind of see them up in here. These actually have 9 vanes in the manual. If like I mentioned before on the others, if you've got the newer machine that the in-cab, they go to 8. Minor difference there. But these, you can see we have 3 different settings where we have to loosen the bolts up here, slide this up, and we can go between fast, medium. These happen to be setting in the slow setting for vanes. And I'm assuming on this we were trying to control a little bit of rotor loss. And that's another important point. It's hard to see up here. The front vanes are in the medium setting. And typically I don't recommend this. What I would say in this scenario, if we're fighting rotor loss and we think it's a vane issue, I would go up to the front and slow these down. Because again, you got to remember, as our thresh process starts at the front of the machine, if we're fighting rotor loss back here, it's telling us, hey, you need to back up and do a better job of separation up here. Because again, we're looking for 70 to 80% of the separation. 100% of thresh, 70-80% of the separation up here. If we're failing with that, we're moving the material too far back in here, and then we're trying to play catch up. So what I would suggest, rather than doing this treatment, is move back up here and slow the veins down in the front up here. Leave the material in the front longer, let it get to that 70-80% up here. Then when it comes back here, we don't have as much to clean up. What I don't care for about this scenario is if we slow these way down, we're kind of, all of a sudden we have the material moving through here at a certain rate, and all of a sudden we're trying to slam the brakes on it once we get this far rearward. Kind of constipates the whole machine. I would much rather leave this in medium, move up here and slow these down. Now I understand that this is not a 5-minute job to adjust these, but sometimes it's well worth the time it takes to move them. Again, these front ones, the front 5 up here will do you more good moving it rather than these rear 4. Again, probably best off in the medium setting back here. Now granted, on the in-cab adjust, we're moving 6 and then just 2 stationaries in the front. The other note I want to make about the difference in the vanes, I will say that the older style manual stainless steel ones move the material through the cage a little more smoothly, probably than the newer cast ones. And it simply has to deal with those new vanes are quite a bit thicker in a cast, and I just don't feel we get quite the same flow with them. So it does affect a little bit on our settings a little bit. Again, the metal medium setting here, most of the time we'll set these medium front to back and we can get along with that. It is certain conditions where we have to fine tune that a little bit to tidy up some rotor loss. So just a quick view again, different age machines. Majority of them out there are probably going to be set up with this until we get up to the 50 series with the in-cab system. So for the rotor itself, we can't really see it very well in here, and that's where we're going to jump to the next segment where we've got it out of the machine. We got some concaves laying there, and we get a much better look of what we're looking for on the rotor and how it's going to help us with our thresh process. All right, for this particular segment, we want to go over the basic rotor itself. This is the heart of the machine. This is where all the threshing and separation goes on, as we alluded to earlier. But I just wanted to get you a view of one out of the machine so we can understand the different sections and how it relates to our concave or grate selection below, and give you an idea what components are on the rotor and what we're doing. I think the more you can understand what's happening with all the noise that's going on underneath you as you're going through the field, it makes it a little bit easier for you to set the machine as you're going through the field. So again, we've got 4 distinct sections. We have 2 threshing, 2 separation. And I've kind of spray painted some lines on here to give us a rough idea of where we're splitting this and how they coordinate with our grate concave selection below. So again, in the front, we're coming out of the transition cone. Hopefully we've got our crop mat organized. It's coming up the feeder house nicely, and we're feeding in here. The impellers, of course, are off of this one right now as it's for the device to get it out of the machine. So as we're going through here, we're going to enter in the machine. Now you can see on here, we have some new rasp bars on the front. And this is quite typical of what these machines do. As time goes on, the front ones are going to wear worse. And then as we go back, you can kind of see they're starting to wear. The front ones were extremely wore. So here's an example of what a front one gets to looking like after a while. It's just wore down severely. And a real telltale sign is you can start looking at the bolt that holds this in place. And as it's rotating, if the bolt head is starting to disappear, then it's time that this needs to be replaced. But as in this example, we can get by with probably just putting some of the front ones on. And again, you have to do the whole rotation around to maintain balance. But you can definitely put on the first section and then maybe come back in the next year and do the rest of it. Split it up in thirds, however you want to do. Some of these, again, you can tell they're wore some, but they're still effective the way they are. And again, as we've discussed in the past, the majority of the thresh is happening up in this right front corner. So as material comes in the machine, these are doing the brunt of the work for the threshing. And then as we start moving rearward, we're more into a separation mode. Now you can see in this case, they've left the rasp bar off of this stand. And in many cases we do that. This one is actually, the way it's in the machine is almost clear up in the transition cone. There's been a lot of discussion over the years whether that's really doing us any good, and we found we just leave the bar off. Some people have gone to the extreme where they've actually cut the stand off also, and you have to be a little bit careful of that, of maintaining rotor balance. And we've never really found that to be that beneficial. But we have started just leaving the rasp bars off the front because they're really not doing a whole lot of work, because again, that's out in the transition cone. So as we are looking at this, again, thresh, separation, separation. And again, our grate selection, we're going to go through that in a little more detail later. But what I really want to point out for the separation aspect is these two units right here, or actually I should say 4. On all of these machines, whether you're back to an 80-10 or up to 9250s or 60s now, you definitely need at least 4 straight bars on section 3 and 4. The other 2 of them are down over here on this side, so they're opposing. But the purpose of what their purpose is as our material is flowing back through the cage, it actually disrupts the circular pattern. So basically it's taking our crop mat, tears it apart, and it has to reform. Well, if that's going on, we're letting the grain that is trapped in that crop mat come loose. Centrifugal force is going to throw it out. So these are a huge aid in separation for corn. Now I have caught several machines. This past fall I found 6 different ones that were missing these simply because of the way the machine had been ordered initially. You got to remember, this rotor is pretty much universal, so it's used in a lot of different crops and can be ordered in different element configurations. So we have found in several cases where they just simply got ordered in a configuration that did not have straight bars on it. But I can guarantee you in corn, you're going to have fits ever controlling rotor loss without these. So I highly recommend everybody go out to your machine, looking again, section 3 and 4 towards the rear. Look to make sure you've got at least 4 of these in here. Now if we look back or think back to mid-range combine days, 2388s, essentially the same rotor, but those always came with 8 straight bars on them, which again was on there to help with separation. But it was a bit of overkill because we had, with 8 of them in there, it just gets to be too much. The only scenario where I could see maybe using 8 of them on a flagship combine is if we're getting into a 16-row corn head, or if you're doing a lot of early season high moisture corn for maybe cattle feed or something. There raises a case where we may want to add 4 more of them on here, and they would basically kind of go in this area in between the existing ones. So in soybeans, these things really aren't our friend, but it's probably not worth our time to take them off between corn and soybeans. Because in soybeans, we don't have that much of a volume of yield, of course, crop-wise. And they're not doing us a lot of good just in the separation element, but they do drag your horsepower down because it is mixing that crop mat, and if we have a pretty wet, sticky soybean mat, they do rob a little horsepower from us, but it's not to the point where it's worth taking these 4 off just for soybeans and then coming back with them. If you do put 8 of them in here, you would want to get 4 of them out before you went and did soybeans. So again, just an overview of the elements. One other thing I want to point out is if we look at our elements here, there's some of them on the rear that are a little bit different, and these are what we call hook ones. And they add a few of these in the rear section on these, again, to help tear up the crop mat. These are predominantly a rice wear element, and a lot of times on a rice rotor, they will load this whole thing up with these spike bars on here. And again, just to help tear things apart. We don't need them for corn, soybeans, oats. Again, this is all we need. But if you're wondering, in the back, more than likely you're going to have 8 of these, because there's 2, 4, 6, 8 down over there then to show you what those are. But for the most part, your elements are going to look just like this, flat surface, hook one's got a little bit of a point. The other thing to take note of on the rear of the rotor is this angled bar back here, and they're called kickers. There's only 2 of them, here and here. Their purpose is, once we've brought the crop in, threshed it, separate, we're going to need it back here, and they're just in here to help us get it shoved out of the cage and push it back into our rotor, or the chopper area back here. So you have 2 of these in the back, and that's what their purpose is, just to help move that material on and kick it out of there. That's why they're called kickers. So right now I'm going to move this rotor element out of the way, and we're going to talk about our concave grate selection a little bit more. I think it's a little bit easier. You kind of get an idea what everything's looking like in the machine now. I'm going to scoot this out of here and we'll pick up again on concave selection. All right, this segment, I've moved the rotor back out of the way. We can see better what's going on. There's a lot to talk about in concave selection and grate selection. So what we have laying in front of us, very typical corn, soybean country type of setup, where we have 4 large wires in the front, and we just call them large wires because of the wire size and the spacing. 4 of them in the front, and then we go back here for separation. We have 4 what we call skip wires, essentially the same size wire, but they're just every other one is missing to give us more separation area. So in our rotor, with the rotation of the rotor, we have the majority of the material and action happening in the right front corner. As you sit there, again with the rotation of the rotor, how it's spinning, everything comes feeding in here out of the transition cone, and you get probably 80% of your thresh is happening here. We finish the thresh out in these other section 1 and 2. We start doing a lot of the separation here also, and then we finish the separation in the rear segments. So again, this was a standard setup for the longest time, starting with 8010s and on back. Excellent setup if you're doing oats, which we're getting more and more customers into the oat market. This is a setup you want. And also for the most part, soybeans. This is probably the preferred setup. And we're going to talk a little bit more of other segments, but this is a good starting setup for soybeans, oats. Now when we get into corn, some things we can run into is with large wires, and you start getting into some wet shuck situations, we're going to have more and more material that starts hairpinning and it almost starts plugging these. So then once you've plugged it solid, we might be doing some thresh yet against the surface, but we can't get the crop through down to the grain pan. So that creates a problem. If we're all plugged up in the front, we lose the majority of our separation, which again, we're going to do all the thresh up here, and 80% of the separation gets done here, or hopefully, and then we're finishing our separation in the rear segment. And again, it depends on your crop yield, moisture. Might be more of a 70-30 split in some scenarios, but we still want to be able to get a lot of the separation complete up here. Well, if we're half plugged up, we're not able to. So what we can do at that point is we're going to start adding in some round bars. A round bar concave has been out for several years now, and they just have a more open profile, and they allow us to get a better separation and are less prone to plugging. So what we have in front of us now is our preferred setup for corn, and will work in most cases in soybeans, but not always. So what we've done is we've scooted out our large wires, except for number 1 right. You may get some scenarios, I think the machine can even be ordered that way, where you would have another round bar up here in that location, but you don't want it there. And the reason why is, if you get in really good threshing drier corn and you have a round bar in that corner, you're going to flood the right side of your grain pan because it's doing its job but almost doing it too well. So it threshes and it lets too much down through. So this one on this corner, still going to thresh, it's going to sweep the grain a little bit more that way before it dumps it through. We get a much better distribution on our grain pan. The other thing about this corner, I've had many customers say, well, if I take my side panel off, this one appears to be starting to plug up and look, or what we call shagging. And on the right front corner, that's fine. It's actually helping you because the bars are still exposed here, so we're still threshing away. And if the grain can't get through, it is going to carry it over a little bit and push it down through the rest of the way. So what that really means is, again, we got a majority of our thresh going on in this corner, and just the design of it, because of the rotation of the rotor, we're trying to help ourselves out a little bit with how we distribute the grain on the pan, because once we transfer it from the grain pan back to the sieves, we want that crop mat, grain mat to be reasonably level. As we look at this between round bar and large wire, we just have a much more open profile, and you can see the material flows through here much better, less prone to plugging with that green material going through there. This is by far the preferred corn setup. Will it work in soybeans? Yes, it will, but we got a couple things to consider. Is if we're in early season soybeans, the problem we're going to run into with this layout is we're not going to get enough thresh. Those over there, that profile is a little too smooth, a little bit too open. We're going to grab too many of those early season green pods and just poke them down through, and they're down on a grain pan, you can't do anything with them. So when we're in early soybeans, you're going to want to preferably have all large wires in. And I realize it's a little bit of work to change them out. If we really have to cheat in soybeans, we can get by with this. This could be your early season soybean setup. I can live with this. It's going to be up to you and what your grain tank looks like. I would say anytime we're starting soybeans, you have to be at least this layout as a minimum. Depending again on crop moisture and things like that. If we still fight too many green pods, then we're going to start changing this row out and get our large wires back in there again. Because again, this is by far preferred for soybeans. Late season, when they get a little drier, easier to thresh, we can live with some other stuff. But this is by far the best setup if you're going to be going back and forth between corn and soybeans. So one other variable they give us is they have come out with, a couple years ago, a large gap round bar. All right, as we talk about a large gap round bar, or what they call a 25 mil round bar, bar is the same size, but our gap is bigger. Reasonably, you can barely get your finger through here. Here you got all kinds of room. So they do have a purpose. They came out with them 2-3 years ago. They really just became available last year. So we're going to talk about why do we need this, where and when we ever going to use it. 25 mil round bars at? Well, in my opinion, they are a section 3-4 only scenario. And you're going, well, why do we need them back there versus up front? Well, the scenario where we're going to need these, I'm going to say, is going to be in a higher moisture corn setup where we're starting to have problems. And you can plug large skips in corn. It does happen in certain conditions. If it's super sloppy green shucks, early season, you can start plugging them, and then we're right back to what we were discussing earlier, is we can't get the material through here, you're not going to get it separated, it's going to move out the back of the machine as rotor loss. So simply by adding these in here, again, much more of an open profile than even a round bar, and it helps prevent the plugging that we might see with these, or shagging, whatever you want to call it. So this would be my high moisture corn setup right here. Bars. We're going to come in with a pair of 25s, and we're just going to leave the large skips in the back. In an extreme condition, you might have 4 of these, but these two, to be honest, are not fun to change. So I would say, if we can't get it done with this, we might want to let the crop mature a little bit, because this would be my super wet corn setup right here. By having all this laid out on the floor, and again, right side of the machine, we're sitting in here like this, right side, left side, different segments, each has their own job. Again, majority of the thresh, a little more thresh, and starting into a lot of the separation back here. That's kind of the layout. Do we have a lot of choices? Yes, we do. And some people have said, well, it's too hard to tune these. In my book, it's great because it gives you the opportunity to adjust this to your crop condition, whether it be wet, green, whatever you got going on. Helps us fine tune the machine to get it to perform the way you want it to and minimize our crop loss that way.
Hey, thanks everyone for watching. This brings us to the end of this video segment. I hope you found it to be beneficial. If you would like to see more in this video series, by all means go to the Red Power Team website, which is of course at redpowerteam.com. Navigate up to that video icon at the top, and from there it'll bring up the menu of the rest of the videos that you can watch, whichever ones you find interesting. Thank you.